Hi everyone, I am Zach Cutler, and this paper is reVISit 2, a full experiment lifecycle user study framework. The visualization community runs a lot of user studies for a wide variety of purposes. Studies include investigations of human perception, studies on visualization techniques or interaction techniques, to studies on trust or insights, all the way to studies on full visualization systems, just to name a few. As you would expect from such a wide range of studies, the exact details of each study is almost never the same. From type of stimuli, to study design and randomization techniques, to data collected and analysis strategies, there are countless options and decisions that the study designers have to make and then implement. As a result, most researchers turn to experiment frameworks to help them implement their studies. The most common, of course, is Qualtrics. However, many other tools exist, two of the more prominent being PsychoPy and JSPsych, which are strong tools. However, none of these tools were built for the visualization community, which runs and analyzes studies with interactive stimuli that rely on modern web frameworks and technology that these tools were simply not designed to support. The result can frequently be some really unpleasant dev experiences and difficulties shaping these tools to do what our exact study designs require. We believe that our community would benefit greatly from an experiment framework tool which is built for us and for the complex study designs, interactive stimuli, and multimodal data critical to our studies. Additionally, Qualtrics specifically is a commercial tool which requires an expensive license that not every researcher or institute has access to. As a result, studies ran on Qualtrics have less transparency and less reproducibility, which should be critical aspects to a user study. That is why we originally created reVISit, and why we in this paper introduce reVISit 2, a full experiment lifecycle user study framework. reVISit is a usable, proven tool with features aimed directly at the visualization community across what we call the experiment lifecycle, which includes 5 stages: experiment design, debug and pilot, data collection, analysis, and dissemination. In this talk, I'm going to walk through 3 of these phases and demonstrate many of the features that we think sets us apart. Quickly first, for the other 2 phases, those being data collection and analysis, tools already exist that do a great job of supporting these phases, and so our features are mostly aimed at connecting people with those pre-existing tools. For example, reVISit itself relies on platforms like Firebase for data storage and crowdsourcing platforms like Prolific to find and pay participants. And for analysis, we have no desire to compete with Python or R for quantitative analysis, so we allow researchers to export their data in a useful format and go do whatever they want with it. However, we do have analysis tools for more qualitative data, such as a qualitative coding interface and participant replays, which I will show in a bit. So first, let's jump into experiment design. And for experiment design, the first thing I want to talk about is the stimulus. reVISit has many options for experiment stimulus. The most direct one is via React components, as reVISit itself is built in React. But we also support any web component, and external websites can be embedded via iframes. We also have support for Markdown and images and videos. And as a tool for the Viz community, we support Vega directly in our config. Next is data collection. reVISit has a wide variety of form elements, such as all the classics, checkboxes, drop-downs, sliders, and much more. But Viz studies aren't just surveys, and this is not a survey tool. We also have features for collecting multimodal data, such as audio recordings and screen capture. And we also collect provenance data automatically on all form elements, automatically on all Vega visualizations, and also allow users to collect and save their own provenance tracking for custom stimuli. Finally, reVISit also has a variety of libraries, which are components or tools that are commonly used in visualization studies, such as VLAT, CalV, BoViz, NASA TLX, and many more. These libraries can be included within a study, both in their entirety or kind of chopped up as individual components. And finally, the last part of our experiment design is the sequence, which controls study flow. Here is an example of a sequence in reVISit. Sequencing is a notoriously difficult part of implementing user studies and is where the aid of experimental frameworks is perhaps most important, which is why reVISit has quite a few key ways to create both simple and complex sequences. The reVISit sequence is made up of blocks. Each block has a few properties, most importantly an order, which can be either fixed, random, or Latin square. Each block can optionally show a subset of its components, as this Latin square block does, only showing one of its three components, effectively producing a between subjects study design. And then, of course, each block has its own components, which are the actual tasks that a participant sees. Two of our components here are actually very small libraries, the audio test and demographics components. Now, here is the actual JSON code required to create this sequence. And I show you this to emphasize that our focus when designing our sequence was to be as expressive as possible in order to support as many study designs as possible. However, one drawback of this approach, as you can hopefully see here, is that our sequence has 0 abstractions, which for a study with a simple design like this one is great, but for something more complicated can become a problem, and this file can really grow pretty quickly. So to ease some of these burdens on the study designer, we developed a separate Python library named reVISit Py, which was largely inspired by Altair's relationship with Vega Lite, and is a declarative library for creating studies, which may be burdensome to create by hand in JSON. reVISit Py is also great for prototyping studies, as you can create entire configs and actually run the study within a Jupyter notebook, and also export the data from the study back into the notebook to test your analysis code and make sure data collection is working as expected. And finally, we also have features to support what we call dynamic sequencing. So this study is a just noticeable differences study, which is an example of a staircase study design, where the parameters of each task, in this case the correlation values of these two charts, are dependent on the answer of the previous task. So if a participant gets it right, the difficulty goes up. If they get it wrong, it gets easier. For these complex studies, we have what we call dynamic blocks, which let study designers define their own function, which determines new tasks and task parameters as participants progress through the study. All right, next, let's talk about the debug and pilot stage. First, we really have put a lot of effort into making the dev experience as painless as possible in reVISit. So changes to your config and to your sequence are immediately shown in this study browser, which we've already been looking at, and which also has tools for testing randomization and debugging stimuli. And to be clear, this is a dev tool that, of course, can be turned off for actual data collection. Another feature that we have used extensively for piloting, although it was actually initially designed for analysis, is our participant timeline and participant replay. So for every participant that has completed the study, we can see how long they took and how well they performed, both for each task and for the study as a whole. If we click on a single task, we jump into the participant replay view. And below our study stimulus here, we can see a timeline of provenance events that occurred during the task as tick marks, as well as the audio, in this case for a Think Aloud study. The stimulus above is rehydrated using the provenance data, letting us see exactly what the participant saw during the task. Here is what it looks and sounds like in practice, and hopefully this audio works.
I wonder why only so many colleges are on here. Like my grad school program is not on here. Let's see. Straight Berkeley.
So we've seen that this is a fantastic tool, both for qualitative analysis, but also for piloting, to understand why people got questions wrong or where they got confused. Finally, as part of our goal of improving reproducibility and transparency of studies, we have dedicated features for dissemination. Once a study is complete, designers can turn off data tracking on the study while giving public access to the study browser, participant replay, and the rest of our analysis features. This lets reviewers or other interested parties walk through the study and see the results for themselves without actually being tracked in any way. Also, with our participant replay, researchers can include deep links to individual tasks or even specific timestamps to demonstrate task strategies or to link directly to a quote in a paper. As part of this paper, we utilized all of these tools to replicate as well as expand on these 3 published studies, either by adding new visualization types, adding provenance tracking, or adding audio recording, as well as some mixture of the 3. In the process of implementing these studies, we learned a lot about the tool ourselves, and this knowledge we also built on by running an interview study with 3 researchers from the community who were not part of the reVISit team, but had all used reVISit to run at least one user study. We learned quite a bit from these interviews, but one main takeaway for us that we learned from is that despite our original intentions of building a tool which was usable across the spectrum of technical skills, reVISit can be really difficult for non-technical users to pick up and can have a pretty steep learning curve. P3 told us some people do not have the computational knowledge of web designing. It's really difficult for me to suggest that they use reVISit because you need to tune actual code. However, the flip side of this is that the highly technical users who have used our tool so far have taken advantage of the open nature of the tool to shape it into their exact requirements. P2 told us if I need to change something in its guts, I can do that, which is fun, as opposed to something more closed. All 3 of our participants told us something similar, and all 3 actually modified the core reVISit code, which we had not intended for them to change, but is all a part of the workspace of any reVISit study. So for us, we think that the open, customizable nature of the tool is actually a great spot to be in, and that we can now kind of work backwards to reduce some of the complexity for researchers who don't want to or can't modify core code, while leaving open the possibility for those who can. We are still very actively developing reVISit. We recently released version 2.3 just a few weeks ago and have much more planned. This has been a massive team effort from so many people, so huge shout out to all the authors on this paper for their contributions and everyone else who has contributed to reVISit. We've also absolutely loved seeing the adoption that we've gotten so far from the community. There's actually 3 papers at this conference that have used reVISit, which is awesome. We also have a Slack channel here. There's a link and also on our site. The Slack has help channels and whatnot. We'd love it if you joined our Slack, gave reVISit a try, and gave us feedback. Thank you.
Thank you very much for putting together this nice tool. I think that will be really helpful. Please walk up to the mics to ask for questions. I think there's one coming up. Please, go ahead.
Hi, awesome. Yeah, thanks for all your work. It seems like a super cool tool. I wanted to ask about the open source ethos behind the tool. So for example, if I make a new React component that I think will be broadly useful, if I want to change some core functionality, is there like a procedure for doing PRs and updating the core code?
Yeah, so great question, thank you. So the way that we actually currently recommend that you use reVISit is to essentially go to our GitHub, it's of course all open sourced, and to either fork the repo or use it as a template repo. So with that nature, kind of what it sets up is that you have all of the core code with you, right? You're in this fork. Yeah. So you can either A, just kind of fiddle with some stuff to get your exact study the way it wants, or B, and maybe preferably for us, if you do implement something new and kind of some new library or whatever, then yeah, we would want you to open a PR, send it back to us, and get reviewed, yeah.
Awesome, thank you.
Yeah.
Let's continue over there, yeah, please.
Hi, Enrico Bertini from Northeastern University. So first of all, congratulations. It's rare to have infrastructure type of work here, and especially that is awarded. It's really, really hard, so congratulations.
Yeah. Thank you.
I was wondering if you thought about maybe a positive unintended consequence of doing this is also that over time, if there's enough adoption, we will have a central repository of how we do studies in this. And if you've been thinking about that, because that would be a really, really cool unintended positive consequence.
Yeah, I totally agree. It's a really interesting question. Actually, I was thinking about it just the other day. At my DC, a couple of people kind of brought something up similar, that these configs, and especially them all being in the same DSL, that at some point we will have enough of these that we can even kind of analyze, what kind of studies do we run, what is our typical study design, how frequently do we use think aloud, et cetera. So yeah, I totally agree. I think it's really interesting.
Thank you.
Yeah. Right, third question from over there. You were first, okay? You go first.
Okay, hello. Hi, I'm Isaac from Georgia Tech. Thank you for making this wonderful work. And as one of the frequent users of this system, I was wondering, what would be the next step of reVISit? For example, assuming you're making reVISit 3, what would be the key characteristics or features, functionalities that you're planning to make it?
Sure. Yeah, so our immediate next steps are both to kind of branch out a little bit outside of the visualization community, especially some other communities like psychology or NLP. There's very specific features that they would need to kind of run studies, like specific timing, for example, which we haven't fully explored yet. And within the Viz community, we also kind of, on our own, we have some very interesting future stuff lined up, such as being able to detect AI usage on prolific, stuff like that. But I will say that especially for more Viz features, we would love to hear feedback from the community and kind of tell us what they would want or need for future features, for sure.
Okay. Thank you. Now it's your turn, please.
All right. Hi, Ulrich Günther, Heimatzentrum Dresden-Rossendorf. Thanks a lot for that great work. That makes our life probably a lot easier. I was wondering if you have some kind of API for any kind of software you want to test that's not web-based, or if you accept PRs for that.
Yeah, great question. So currently, no. It's something that we've been exploring, and there are some brute force ways of doing stuff like this. Like if we want to run like Jupyter Notebook is probably the most obvious example, right? If you want to run a study in a notebook, the brute force way would be throw it in a VM and then in a browser, something kind of brutal. So currently, no, but something that we've definitely thought about and hope to do soon.